Hello sir, this is my ELP project on the topic transformers. So first we need to understand that why do we need transformers. The need for transformers arises from the need of generation of electricity itself. At the sites where electricity is generated, it is generated at very high currents. The higher the current, the more will be the joules heating loss in the transmission lines. It is related by the relation I square R dt. This is the DH or the differential heat that is produced. So in order to tackle this problem, we basically use a step up and a step down transformer. A step up transformer basically increases the voltage at the initial starting point. This increased voltage will cause a decrease in current due to the conservation of power, and less current will cause a very small loss due to heat and increase the efficiency. At the areas where we need to use this electricity, we will basically use a step down transformer to reduce the voltage, which is at a typical of 10,000 volt to a domestic purpose voltage of 440 or 220 volts. Now we will see that the transformer basically works on the principle of induced EMF, and induced EMF is produced only when a varying magnetic field is there, and this will happen only in case of alternating current. So a transformer will not work in case of a direct current. So this is the generation of electricity. A generator basically generated electricity in the principle of magnetic induction. A varying magnetic field induces an EMF. So this current produced or the voltage produced will be in the form of a sine wave. The vertical line which you can see is the neutral point of the current produced. So this is the schematic diagram of a transformer. So the transformer basically works on the principle of conservation of flux. So the more flux, the more number of turns you have, the less amount of induced voltage you will need to sustain the flux. So this is basically given by n phi. N d phi by dt is equal to the E. So more the N, less is the more is the E required to sustain the flux. So the relation between the left and right coils is simply given by E1 by E2 equal to N1 by N2. Here E1 and E2 are the induced EMFs respectively, and the N1 and N2 are the number of turns. So now we come at the core of the coil. The core of the coils is basically an iron core. This is done so that very less amount of magnetic flux is lost to the surroundings. So if we place a very solid core instead of the core used today, a lot of heat will be lost in the form of eddy current or the copper loss. So in order to tackle the eddy currents, what we basically do is replace the iron core with a lot of laminated sheets of thickness T. So now the power loss will be given by K B square F square T square. Here K is the eddy loss coefficient, B is the maximum field, F is the frequency, and T is the thickness. So here you can see that if we replace the core with very thin coils and a large number of coils, so this will greatly reduce the eddy current, and hence our transformer will be more and more efficient. So this is the transformer which we currently use for day-to-day purposes. So this is the schematic diagram. This is the diagram of a three-phase transformer. So why do we need a three-phase transformer? So a three-phase transformer has basically a lot of edge over a single-phase transformer. It is highly efficient. It has very less losses. Its cost of repairing is high, but the need to repair it is very low, and it is very extensively being used today. So the outer part which you can see, it has the high voltage coil. So the high voltage flows in the outer part, and it is stepped down to the low voltage side using the inner green part. And the core which you can see is basically made of lot of laminated sheets of iron. So the two cores which are basically present inside the transformer can be connected via delta connection or can be connected by a Y connection. So this is the basic working of a transformer. Thank you.